of you. Today's topic is exact differential equation. What is the exact differential equation and how we can find its solution? Normally, in case of formulation of differential equations, there are two important steps. First step is we have to differentiate the given parametric curve as many times as it has the independent arbitrary constants. And in second step, we have to then eliminate the arbitrary constants in order to get the required differential equation. These two important steps are involved while forming a differential equation from its general solution. So if in case of formation of differential equation only step 1 is required, that is, which means that step 2 is not required, then such type of differential equations are known as exact differential equations. Thus the formal definition is a differential equation is exact if it can be obtained from its general solution by directly differentiating it without any subsequent multiplication, elimination, reduction, or any operations which we used in formation of differential equations. And the necessary and sufficient condition for the differential equation of first order and first degree. The standard form of first order and first degree is m dx plus n dy is equal to 0, where m and n are functions of x and y. Then this equation is said to be exact differential equation if we differentiate this function m partially with respect to y and this function n partially with respect to x. If both the partial derivatives are same, then the given equation is known as the exact differential equation. And this condition has to be verified whenever we have to show that the given equation is an exact differential equation. And now the working procedure to find the solution of the exact differential equation. Suppose m dx plus n dy is equal to 0 is an exact equation, means this condition is satisfied. Then we have to integrate this function m. In a step first, integrate this function m with respect to x, keeping y as constant. And then we have to integrate only those terms of n which do not have x with respect to y. And then finally we have to add the results obtained from step 1 and step 2 and equate with an arbitrary constant, and then that form will be our required general solution. Or equivalently, these three steps are combined in a single one. We suppose we have to write the general solution of the differential equation m dx plus n dy is equal to 0, which is exact equation, and then its general solution can be written directly in the form of we have to simply integrate this function m with respect to x, taking y as constant. This is our first step. And then integrate only those terms of n not containing x with respect to y and is equal to c, where c is the constant of integration. Using this result, we can write the general solution of given exact differential equation. For example, suppose we have given this example that we have to compute the value of lambda, for which this differential equation is given as an exact differential equation. Then we have to find its solution, hence solve it. So given that this equation is exact, so we have to compare the given differential equation with the standard form of first order and first degree differential equation, which is m dx plus n dy is equal to 0. And comparing with this standard form, we have to first compute the function m and the function n. Here this is m function and this one is our n function. So in order to verify that as the as it is clear that the in the question that given equation is exact. If it is exact, then it must satisfy the condition, which is del m over del y is equal to del n over del x. So for this we have to first compute the partial differentiation of the function m with respect to y, and the partial differentiations is computed in ordinary sense by simply differentiating this function with respect to y and keeping all rest variable or remaining variable as constant. So the partial derivative of this function m with respect to y is 2xy plus lambda times 2x cube y, and the partial differentiation of this function n with respect to x, we have to first multiply this expression with x. The result is x raised to the power 4y plus y x square, then differentiating with respect to x. So the derivative of first term x raised to the power 4 is 4x cube y plus 2yx. Here, since the given equation is exact differential equation, so this condition always holds. So using this condition, we have del m over del y is equal to del n over del x, and simplifying it, we have obtained lambda is equal to 2. So lambda is equal to 2. For lambda equal to 2, this equation is basically an exact differential equation, and in order to get its solution we have to follow the procedure, and the procedure is we have to integrate this function m with respect to we have to integrate this function m with respect to x, keeping y as constant, and then we have to integrate only those terms of n which do not have x. Here all the terms involve x, so here no term of n which do not have x. So here the second term is plus terms of n not containing x, we have to integrate it with respect to y is equal to c, where this c is the constant of integration. Now integrate this expression with respect to x, keeping y as constant, so the integration of x is x square by 2, and the integration here lambda is obtained as lambda is equal to 2, so put lambda is equal to 2 in this form, and we have to integrate this expression with respect to x, keeping y as constant, so integration of x cube is x raised to the power 4 by 4 and this term is equal to 0 is equal to c. This is our required general solution, where c is the constant of integration. Now suppose let us consider one more example, and we have to suppose solve this differential equation. First we have to write this differential equation in the standard form, that is m dx plus n dy is equal to 0. So we have combined all the terms of dx in all the terms of dx and all the terms of dy. So this form is obtained. Now equating this form with the standard form and obtain the functions m and n. Here m function is this one and n function is this one. And in order to get the solution, here we first verify that whether this equation is an exact differential equation or not. Suppose if it is exact, then we can establish its solution directly using the known result, which is this one. So in order to verify that it is exact or not, we have to compute the partial differentiation of m with respect to y first, and then partial differentiation of n with respect to x. So these two partial differentiation are obtained, and here we have observed that both the partial differentiation are same, which means that given equation is an exact differential equation. Hence its general solution can be written in this form, where the first term is we have to integrate the m function with respect to, this is our m function with respect to x, treating y as constant, and plus terms of n not containing x. We have to integrate these terms with respect to y is equal to c. This is the form of the general solution of an exact differential equation. Here m function is this one. We have to integrate this function with respect to x, keeping y as constant. So integration of x is x square by 2. Y is constant, a square y is taken out from the integral sign. So integration of 1 over x square plus y square is in the form of 1 over y tan inverse x over y, since y is treated as constant. And the integration of terms not containing x. This term has x. So this is only one term which do not have x. So we have to integrate y with respect to y, and the integration of y is y square by 2 is equal to c. And you can further simplify this one in this form, which is our required solution, that is general solution of this differential equation. So in order to get the solution of first order and first degree differential equation, this is basically an additional method which is exact method. And to get the solution, we have to obtain, we have to verify first whether the given equation, which is in the form of m dx plus n dy is equal to 0, is exact or not. And for the exactness condition, we have to verify, we have to differentiate m with respect to y, and we have to find the partial derivative of n with respect to x. If both the partial derivatives are same, then we can directly conclude that given equation is an exact differential equation. And if it is exact, then the form of its general solution is always in this form, where we have to integrate m with respect to x, keeping y as constant. This is our first term. Plus we have to integrate only those terms of n which do not have x in with respect to y, and finally equate with c, where c is any arbitrary constant. So using this result, we can write its general solution. Thank you.